Okay, this is a pre-calculus concept. Okay, I am recording this in my Algebra 2 Honors Bridge class, but this is a pre-calculus concept. So Algebra 2 people, you can kind of ignore the first 2 or 3 minutes of this. So we have our difference quotient. The difference quotient is, if you look exactly what it is, a difference and a quotient. We use this in calculus, okay, to come up with the limit definition of a derivative, which then leads into basic derivatives, which leads into many, many different concepts in calculus class, okay? But embedded in this idea is something that my Algebra 2 kids need to see, so I'm gonna go slowly. Now, everything in this difference quotient has a placeholder. For example, like h is h. I'm not gonna do anything with h right now. F of x, okay, is this. So when I'm using this almost as a formula, okay? Nothing is going in for h. F of x is going to be replaced by this, because this is what f of x is. I need to figure out what goes here. Okay? In basic function notation, if f of x, let's just go through that. I'll come over here and then I'm going to erase it because I don't have whiteboard space. If f of x is 4 over x, then f of 3 is 4 over 3. Right? Whatever I put here goes in place of x. If f of a is 4 over a, I can do this all day. I could just keep putting different values in for the input. They just slide right into the denominator. That's what it becomes. Okay? So if that's what we do to evaluate functions, then f of x plus h would be, using the same idea, f of x plus h would be 4 over x plus h. It slides into the denominator, right? F of 3 was 4 over 3, f of a was 4 over a, f of x plus h, very specific to this function, is 4 over x plus h. Now I'm going to be taking this expression, writing it here. I'm going to be taking this expression, substituting it into f of x, and then I'm going to have all of that over h. So it's going to look like this. Butterscotch! Butterscotch! 4 over x plus h minus 4 over x all over h. And the goal is to simplify this into a singular term, if possible. Maybe not a singular term, but something obviously not as complicated looking as this. All right? This is not simplified. This is what we've been talking about in Algebra 2, is if I want to simplify this, I don't want what amounts to be 3 fractions, 1, 2, 3. I don't want 3 fractions. I don't want any fractions if I can get away with it. So I'm going to take this piece by piece. We take the numerator and go off to the side. I'm just going to take the numerator off to the side. And I'm going to try to find a way to put 4 over x plus h minus 4 over x. I'm going to try to find a way to put that together. Combine it into one fraction. Right? To combine fractions, we need a common denominator. The fastest way to get a common denominator, multiply the denominators together. This is the factor of the bottom, right? We've talked about this. That's the factor that's in the denominator already. This is the only thing in this denominator. They have nothing in common, so they have, they don't have a lowest common multiple, they just have a multiple. We multiply them together. So I'm going to take x, I'm going to multiply it times the bottom and the top, and I'm going to take this denominator, x plus h, and I'm going to multiply it times the bottom and times the top. From that, I'll get 4x over x plus h minus, now this is, sorry I squeezed it too far over here, 4 times x plus h. I'm going to distribute that right away, if that's okay with you guys. That's going to be 4x plus 4h over x plus h. Now I mentioned this, I'm going to mention it again. we don't want to actually FOIL, distribute, do anything with the denominators. Just write them as a product. Okay, don't distribute the x. We want to do it in the numerator, take my word for it. There are many applications why we want to do it there. There are lots of reasons why we don't want to do it down here. Okay, now when I combine these, you Algebra 2 people are going to recognize this. You pre-calc people should remember it as well. I'm subtracting a fraction. That fraction, I'm only going to subtract the numerator, but the numerator has two terms. So in essence, what I'm going to have is 4x minus 4x minus 4h, right? I'm subtracting 4x, I'm subtracting 4h. On the bottom I have x plus h. And this all simplifies down to what? Negative 4h on the top, x plus h on the bottom. That's my numerator. All over h. I'm going to pause this because I don't want the video to go too long.